motion in one dimension, and under this topic we are going to study average speed and average velocity. Now average speed and average velocity, I will solve a simple problem. If I ask you, the speed time graph, if I draw velocity time graph or displacement versus displacement time graph, and the graph for two objects, yeah, displacement, someone is getting now, so they can send you the screenshot. They can send you. So displacement versus time graph for two bodies A and B is as shown in the figure. This angle is 30 degree and this angle is 60 degree. Now if the displacement time graph is a straight line, what does it indicate? The body is moving with constant velocity, uniform velocity. Velocity is uniform. Okay. Now the question is, which of the two bodies A and B possess higher velocity? How will you solve it? Which of the two possess higher velocity? So which line represents greater velocity? The question, which line represents greater velocity? Greater velocity. So how will you solve this question? Because the slope of displacement time graph gives you the velocity. So slope means tan theta. Tan theta, slope of displacement xt graph. Xt graph gives velocity and slope means tan theta. So tan theta means the higher the value of theta, tan theta will have the higher value. So 60 degree is more than 30 degree. So tan theta for B, line B is greater than tan theta for line A. Therefore, V for velocity of B is more than velocity of A. If I ask you what is the ratio of the velocity, then how will you find the ratio? That is VB by VA. So then it is tan theta 1. Suppose this angle is theta 1, this angle is theta 2, or this angle is theta 2, this angle is theta 1. So in that case, it is tan theta 2 by tan theta 1. So tan 60 degree by tan 30 degree. So tan 60 degree is how much? Root 3. And tan 30 is 1 by root 3. So the ratio is 3:1. Ratio is 3:1. So let me solve some another problem. Number 1. Number 2. If displacement versus time relation is given to you. Suppose x is equal to t minus 2 whole square. Okay. Now calculate the distance covered by the body in 4 seconds. Calculate the distance covered by the body or object in t is equal to 4 seconds. This is the question. So how will you solve it? X is equal to t minus 2 whole square. So how much distance it will cover in 4 seconds? How much distance? This is displacement time relation. X is displacement, t is in time. X in meter, t in second. So how will you solve it? Yeah? Anybody can solve it? 6 meter. Displacement x is equal to t minus 2 whole square. Calculate the distance covered by the body in t is equal to 4 seconds. This is the question. How much meter? Distance covered by the particle in 4 seconds. Displacement of the particle is given by, this is displacement. Displacement of a particle is given by, displacement is given by, this relation. This is your relation. Okay? 6 meter. So, anybody else? Yeah? Arko Prabhu? Arko Prabhu? Yeah. What will be the correct? 8 meter? See. So, different brains are telling different answer. So, why the answer is differing? Because of the difference in concept. So, at t is equal to 0, x is what? So 2 square, that is 4 meter. So the particle, suppose this is origin. So at t is equal to 0, the particle is at a distance 4 meter from the origin. 4 meter from the origin. The particle is at point A, suppose. Okay? Then at t is equal to 2 seconds. At t is equal to 2 seconds. So if you put t is equal to 2 seconds, the particle will cover a distance equal to 2 minus 2, that is x0. Means the particle, actually this is displacement. So particle will be at the origin. Particle will be at the origin. X is equal to 0. This is x is equal to 4. Okay. So at t is equal to 0, the particle is at 4 meter, t0. So starting t0 here. And then at t is equal to 2, the particle will be at the origin. And if you put t is equal to 4, then what will happen? 4 minus 2 square, that is 2 square, 4, again 4 meter. So the particle will again go to the point A. So how much distance the particle will cover? Particle will move from A to O and then O to A. So total distance covered will be 8 meter. 8 meter. So the correct answer is 8 meter. So at x is equal to, so particle t0 pe initially it is at 4 meter, then at t is equal to 2 seconds, then particle, the distance of particle from the origin will be 0, and at t is equal to 4 seconds, the distance of particle from the origin will be 4 meter. From here, from it is 4 meter from this point O. So the total distance covered is equal to 4 meter plus 4 meter, total 8 meter. Total 8 meter. Yeah? The particle moves like this. And then it again goes to this position. So 4 meter back, then 4 meter again towards A. So total distance covered is 4 meter. Okay. Now I am solving. The distance traveled by a particle in time t is given by the relation. Take the snapshot. I will rub the board. Okay. This is slide 1. So I am writing here 1. It will be easy for you for while writing in copy. Okay, taken? Take it. Then I'm solving another problem. Do you know the magnitude of velocity gives a speed? Okay, the magnitude of velocity is nothing but gives you the speed. Now, is this statement correct? The magnitude of average velocity is equal to average speed. The magnitude of average velocity Is it equal to average speed? Not always. But the magnitude of velocity gives you the speed. But the magnitude of average velocity may not give you the average speed. I will show you by a numerical. Okay, before that, I will solve numerical 3. So, x depends upon t by the relation x is equal to 2.5 t square. This is the relation. X is equal to 2.5 t square. The distance traveled by a particle is in time t is given by this relation. Now find the average speed of the particle during the time interval 0 to 5 seconds. The first bit is find the average speed of the particle in 0 to 5 seconds. First bit is during the time 0 to 5 seconds. And the second question is you have to find the instantaneous speed at t is equal to 5 seconds. Also find the instantaneous speed at t is equal to 5 seconds. This is the question. So the first part is 2.5 t square. 2.5. It's point. 2.5 t square into t square. Okay. So x is the distance traveled by the particle. T is the time. So x distance traveled and time taken is related by this relation. X is equal to 2.5 t square. Now you have to find the average speed of the particle in 0 to 5 seconds within time interval 0 to 5 seconds, and also find the instantaneous speed at t is equal to 5 seconds. Yeah, yeah. I will solve it. Finally, I will solve it. But if you know, then you can say the answer. Yeah. Oh, very fine. So, find the average speed. So, to find average speed in 0 to 5 seconds, you just find the distance covered. So, distance traveled x in 0 to 5 seconds. Just put t is equal to 5. So, x is equal to 2.5 into this t is taken as 5. So, this is 2.5 into 25. So, it's how much? 62.5 meter is the distance covered by the particle within 0 to 5 seconds. Now average speed is nothing but total distance covered, which is 62.5 divided by total time taken. Time taken is 5 seconds. Divide it. 12.3, not 3, no? 12.5 meter per second. Now this is first bit. Now second bit is also find the instantaneous speed. So find instantaneous speed means dx by dt. You have to differentiate it. You have to differentiate it. So then d by dt of x just gives you 2.5 into differentiation of t square is nothing but 2t. This is 5t. Now put at t is equal to 5 second. So v instantaneous speed is equal to 5 into 5. That is 25 meter per second is the answer. 25 meter per second. Written? Yeah. Now I am showing you the fourth question. You have a speed time graph. It's like this. So if this is 0, this is 1, this is 2, this is 3. And this side you have taken speed in meter per second. Meter per second. And this side you have taken time, t, in second. Now you have to find the distance covered by the particle in 3 seconds. So distance covered by the particle in 3 seconds. So particle during the time interval 0 to 3 seconds. So how much? Yeah. This one. This is given to you. So this is equal to, this is 6 meter per second. 6 meter per second. Okay. So find the distance covered. Find the distance covered. Distance traveled in 0 to 3 second. So area under speed time graph, area under speed time graph gives you the measure of distance traveled because S is equal to UT. So distance traveled is, distance covered or traveled is area. So this is the area of triangle, whatever shape is bounded under VT graph. So this is O, suppose this is A, this is B. So area of triangle OAB. Okay, now this is half into base, base is 3 into height is 6. So 3 3s are 9 meter, 9 meter only, 9 meter. Distance covered is 9 meter. Now we start solving some another type of problem, and it is equally important. A man walks on a, taken a snapshot. This is page number 2. Okay, page number 2. Page number 2. Take it. Okay. Yeah. Take it. Okay. Now to find, to just to observe the difference between magnitude of velocity gives you the speed, but magnitude of average velocity may not give the average speed. So the question is, this is actually from textbook. So the question is, a man walks on a straight road from his home to market 3 kilometer away with a speed of 6 kilometer per hour. So suppose this is the home and this is the position of market. And the distance between home and market is 3 kilometer. And the man moves with a speed 6 kilometer per hour. 6 kilometer per hour. This is the scenario. 6 kilometer per hour. Finding the market closed, he instantly turns and walks back with a speed of 9 kilometer per hour. So he instantly turns back with a speed 9 kilometer per hour. Okay, market was closed. So finding the market closed, he instantly returned back with the speed 9 kilometer per hour. Okay, the question is, what is the magnitude of average velocity? The first bit is, what is the magnitude? What is the magnitude of average velocity? Magnitude of average velocity. The second bit is magnitude of average velocity, then average speed of the man over the interval of time. Average speed of the man over the time interval. The time interval is given to you. Over the interval of time, over the interval of time, suppose A part is 0 to 30 minutes, 0 to 30 minutes. The B part is 0 to 50 minute, 0 to 50 minute, and then C part is 0 to 40 minute, 40 minute. Now, this is the question. Now start solving. What is the magnitude of average velocity? So obviously, the average velocity magnitude will be 0. Why it is 0? Yeah, average velocity is actually you have to find the average velocity, not for this part. You have to find average velocity, average speed for these parts A, B, C. So what is the average velocity in 0 to 30 minute? What is the average velocity in 0 to 50 minute? What is the average velocity in 0 to 40 minute? And then what is the average speed in 0 to 30 minute? What is the average speed in 0 to 50 minute? What is the average speed in 0 to 40 minute? This way you have to solve. So first you have to find the average magnitude of average velocity in 0 to 30 minute. So see, the man has to cover a distance of 3 kilometer, okay, and the man starts moving with 6 kilometer per hour with a constant speed of 6 kilometer per hour. So how much time he will take to cover the 3 kilometer distance? Yeah, in 1 hour he is going 6 kilometer. So in 30 minutes the man will go to the market. So distance covered in 0 to 30 minute is already given to you. Distance is equal to displacement because this is a straight line motion. So distance or displacement cover by the man in 0 to 30 minute. It's how much? 3 kilometer. Okay. So average speed, average velocity. First we are finding average velocity. So average velocity is total distance. And now we are talking about 0 to 30 minute. Focus yourself to this time interval. 3 kilometer divided by time taken is 0 to 30 minute. Convert this into hour. So 30 minute is how much hour? 1 by 2 hour. So this is 6 kilometer per hour. 6 kilometer per hour is the answer of first part. Now tell me the average speed. Within that time interval, what is average speed? So average speed is exactly same because distance and displacement will be same. So 3 divided by 1 by 2. Again same answer, 3 kilometer per hour. So what you see, magnitude of average velocity is exactly equal to the magnitude of average speed. Now we are solving for the second bit. This is A. Now B, 0 to 50 minute. So in 0 to 50 minute, the first bit was 0 to 30 minute time interval. Now we are talking about 0 to 50 minute. So what is the displacement? Yeah, in 30 minutes, the man will reach to the market, and then in 20 minutes, if you find the distance covered in 20 minutes, so 9 kilometer per hour means in 1 hour 60 minutes while returning, the man covers 9 kilometer, 9 kilometer. So what is the distance covered in 50 minutes? So in 50 minutes, this is 9 into 50 by 60. You just cancel it. So it's how much? 45 by 6. 15 by 2. That is 7. It's how much? 7 point? Not 50. No. You have to find 20. We are finding displacement first and then we will find distance. So in 60 minutes, while returning, the man covers 9 kilometers. So in 20 minutes, how much distance will be covered? So 9 into 20 by 60. Cancel it. 9 by 3. So it is finally 9 into 20 by 60. So that is 3 kilometer. 3 kilometer. So 30 minutes have already been passed, and remaining 20 minutes, in remaining 20 minutes the person or the man will again reach to home, because in returning speed is 9 kilometer per hour. So in 20 minutes he will cover a distance of 3 kilometer. So he will again return to the home. So what is the displacement? In 0 to 50 minutes it is 0. So displacement in 0 to 50 minutes is equal to 0. But distance is not 0. But distance, we are writing simultaneously. Distance covered in 0 to 50 minutes. It's 3 kilometer plus in returning 20 minutes, that is 3 kilometer. The total is 6 kilometer. So now see the average velocity. Average velocity is total distance by total time. Time is 50 minutes by 60. So this is 0 only. 0 kilometer per hour. Now what is the average speed? Average speed here is not 0. See, the total distance is 6 and total time is 50 by 60. So should I write 6 into 6 by 5? So 36 by 5 is how much? 7.2 kilometer per hour. So now the magnitude of average velocity is not equal to the magnitude of average speed. That is 7.2 kilometer per hour is the average speed. Now for the third bit, 0 to 40 minutes. So in 0 to 30 minutes, the man will reach to the market, and then within 10 minutes, that is 30 to 40, 10 minutes. So after reaching the market, so in 10 minutes, what is the total distance covered by the man while he is returning to the home? So that you have to find. Okay, take the snapshot. So take the snapshot. This is 3, and then I will do the third part. Okay, taken. Okay, let me see. You are right, but still I will solve. C part, because we are doing the for the entire class. We are doing the problem for the entire class, not only for the one children. Okay, taken taken a snapshot. Many of you may not be able to solve it, but many of you can solve. So I'm solving this part, that is C part. Okay, I'm rubbing this portion. So C part. Now C part is time interval 0 to 40 minutes. So in 0 to 30 minutes, the distance covered is how much? 3 kilometer. So now within 10 minutes, how much distance it will cover when the person is returning home? Now in 60 minutes, the person is covering a distance 9 kilometer. So in 10 minutes, how much distance he will cover? 9 into 10 by 60. Just cancel it. So this is 3 3s are 9, 3 2s are 1.5 kilometer. So what is displacement? So the person will reach here. So displacement is 3 kilometer minus this distance, 1.5. So displacement is equal to, because in 10 minutes the person is covering 1.5 kilometer while returning. So then displacement is 3 minus 1.5. So it's 1.5 kilometer. Okay. And if I ask you what is the distance covered Distance covered in 0 to 40 minutes. 40 minutes is equal to 3 kilometer plus 1.5 kilometer. So it's how much? 4.5 kilometer. Now average velocity, which is displacement by time. Time interval is 40 minutes. Convert this into hour. So 1.5 into 6 by 4. 2, 3. So it's how much? 4.5 by 2. So 2.25. Am I right? Kilometer per hour. Now what is the average velocity? Average speed. So total distance covered in 0 to 40 minutes is 4.5. By total time is same, 40 by 60. So in the same way you can write 4.5 into 6 by 4. So it's how much? 4.5 into 3 by 2. 4.5 into 3 by 2. So this is 4.5 into 1.5. Just multiply it. How much you get? 6.75 kilometer per hour. Kilometer per hour. So magnitude of average velocity, now we are very much sure that magnitude of average velocity may not give the average speed. May not give the average speed. So very remarkable line, very interesting line. Magnitude of velocity gives you the speed, but magnitude of average velocity may not give you the average speed. Okay? So after solving this problem, now we are moving towards some other type of problem. Now graph, yeah, yeah. If the motion is not reversible, if the motion is not reversible, if it is going in a straight way without reversing its direction, then magnitude of average velocity is equal to magnitude of, that is, average speed. These two are equal. Because distance then equal to displacement. Distance and displacement will be same thing. But if the reversible motion is there, suppose the person is returning back, then displacement and distance will differ. And accordingly, the average speed, average velocity will be different. Okay, take the snapshot. This one is 4. Okay, page number 4. Taken. Okay, now starting some concept of relative velocity. Relative velocity in one dimension. Actually, the concept of relative velocity becomes much more clear when you will study the motion in two dimension, because the concept of vector is necessary. So if you know the concept of vector, then it will be a little bit easier for you to understand. But okay, up to some point of difference you can take this problem, relative velocity. Okay, before we start relative velocity, now just tell me what is velocity time graph? Velocity time graph for a particle thrown vertically upward. Thrown vertically upwards. Also draw the speed time graph. Also draw the speed time graph. So what will be the answer? Velocity time graph for a stone thrown vertically upward. Okay, if you throw a stone in vertically upward direction, its velocity goes on decreasing because the motion will be decelerated motion. Okay, I will tell you about acceleration and deceleration later on. But just now, you see, you have thrown it with some initial velocity, and then velocity goes on decreasing. At highest point, it will be zero, and then it will start returning back. So when it returns back, this velocity becomes negative, and it goes straight like this. It goes straight like this. So the velocity with which you have thrown it at the same point from where you have thrown, the velocity of the particle becomes same. So, but in direction it is reversed. So that's why we have taken it at negative y-axis. So this is time, this is velocity. But the speed time graph is different from this one. This is velocity time graph, with velocity time graph, velocity time graph. But the speed time graph, speed will never be negative. So that's why speed decreases. Okay, then when it is returning back, speed starts increasing and will attain the same speed as soon as it reaches the point of projection. And that's why the speed first starts decreasing as you throw the ball or anything stone in vertically upward direction. Its speed goes on decreasing. At highest point, its speed will be zero. When it starts coming back, then speed again starts increasing. So speed will never be negative. That's why it is plotted in positive axis only. Positive axis. And again it will achieve the same speed, the point from where you have thrown it. Okay. So this is the speed time graph. Now you have taken speed here and time here. This is the speed time graph. Can anyone say that speed time graph is like this? Is it possible for a speed time graph? A speed time graph. Why it is not possible? Yeah, because the speed will never be negative. And this portion shows that speed is negative. So the reason is this is not possible. This graph is not possible. This graph is not possible because speed will never be negative. Speed will never be negative. Never be negative. Just take the snapshot. I will change the board. Yeah, taken. Taken. Now we will start relative velocity. Relative velocity. Now what is the strength just now? The strength of the class? How much? 40, 41? 47? So 5, 6? So, okay, so someone has left, no? Or maybe disconnected due to slow internet. Okay, so relative velocity in one dimension. In one dimension. Now you have a track. If the two cars or trains, anything, two bodies, A and B, are moving in same direction, then relative velocity of A with respect to B is nothing but VA G, G for ground, earth. We have introduced G for ground. In vector we are writing. We are writing in vector. Okay, I will tell you plus velocity of B, velocity of ground with respect to B. At the same time, I want to tell you velocity of A, velocity of B with respect to ground is negative of velocity of ground with respect to B. Negative. Because these two velocities are in opposite direction. Yeah? No, it should be plus, but I will write just now. So this is VAG plus, now VGB. VGB can be written as minus VBG. So how do you how will you write VGB? So VGB is nothing but minus VBG. If you reverse the suffix, then it will take negative sign. If train is moving towards east, then ground appears to move towards west, just opposite. So two vector in opposite direction. That's why velocity of B with respect to ground is equivalent to velocity of ground with respect to B with a negative sign. With a negative sign. If train is moving, if the train is moving with a speed of 40 km per hour towards east, and you just look the ground appears to move with the velocity 40 km per hour opposite to the direction of train. So same speed. Okay. So then we are writing minus VBG. So two vectors VAG, okay, and then minus VBG. Okay, write it like this only. VAB. If I ask you what is the angle between VAG and minus VBG, your answer will be, yeah, VAG means train A is moving towards right and train B is moving also towards right. This is the observation made by a person standing on the ground. Yeah, this person is observing that train A is moving with velocity VA, that is VAG means velocity of train A with respect to ground. The person is standing in the ground. And the person is reporting about the velocity of train B with respect to ground. Both the trains are moving in the same direction. But I ask you, what is the angle between VAG and minus VBG? Remember, VBG is along this direction. So if you, yeah, 180. So minus VBG means you just reverse this velocity along this direction. So then what is the angle between this vector and negative of this vector? That is 180 degree. If two vectors are opposite to each other, then what will be the resultant? Resultant is simply the difference of the magnitude. So mod of VAB, if you are taking magnitude, then this is mod of VAG minus mod of VBG. So this is VAG only minus, and then negative, mod of negative is positive only. So this is VBG. Now we are taking magnitude only. If VAG, if VAG is suppose 40 km per hour, or you may take 60, and VBG, relative velocity of B with respect to ground, is 40 km per hour, then what is the relative velocity of A with respect to B? Then your answer will be 60 minus 40, that is 20 km per hour. But imagine a scenario when the two trains are moving in opposite direction. Now we are dealing the scenario just opposite. So this is one of the train, this is another train. Yeah? Yeah, tell me. Why? So relative velocity is nothing but resultant of two vectors. Two vectors. This is one of the vector. This is another vector. So VBG is towards right. So what is minus VBG? Towards left. Now two vectors. You have two vectors in opposite direction. This is VAG direction. This is VBG minus VBG direction. So what is the angle between them? 180. And if two vectors are inclined at 180 degree, that is opposite to each other, their resultant is nothing but difference of the magnitude of the two vectors. Difference of the magnitude of the two vectors. Suppose someone is applying a force of 10 Newton towards this side. Another person is applying force of 5 Newton towards this side. So now the two forces are in opposite direction. So what will be the net resultant? Resultant force on the body will be 10 minus 5. So you are just subtracting. Why subtracting? Because the two vectors are in opposite direction. And if they are in same direction, then resultant will be, magnitude of resultant will be the sum of magnitude of the two vectors. Suppose someone is pulling towards this side with a force 10 Newton, other one is also pulling towards same side with a force of 5 Newton. Then what is the total force acting on the body? 10 plus 5. Yeah? Yeah? Same direction. But you have to consider VAB. Final result is VAG plus minus VBG. So you have to see the vectors VAG and minus VBG. BAG is along this direction. Minus VBG is along this direction. So now think about two vectors acting opposite to each other. So what will be the resultant? Resultant will be the magnitude. Magnitude of resultant is magnitude of this velocity minus magnitude of this velocity. So anything whichever is vector quantity, the same rule is applicable. But say this case. Now here VA, VB. So VAB is going this way. This is velocity of A with respect to ground. This is velocity of B with respect to ground, observed by some person standing on the ground. Now you are going to find VAB. So VAB in vector, it is VAG. Again we are writing in the same way. Plus VGB. So this G and this Z will be compressed. Finally what you get? AB. AB. Now this is VAG plus what is VGB? Should I write minus VBG? VGB is minus VBG. Now just see the direction of two vectors. VAG is towards right direction. Now minus VBG. VBG is already along this direction. So if you take minus of this vector, this will be along this direction, towards right. Now VAG and minus VBG are in the same direction. So then what will be the resultant? So resultant mod of VAB is now two vectors in the same direction. So then you have to add the magnitude of the two vectors plus magnitude of VB minus VBG modulus. So this is a VAG only plus and minus mod of minus VBG is nothing but VBG only. VBG only. This is VAB. Now remove the vector sign. So if the trains are moving in opposite direction, then relative velocity of A with respect to B is nothing but the sum of the velocity of the two trains. So if this is moving with velocity 60 km per hour, this is 40 km per hour, then relative velocity of A with respect to B is nothing but this is 60 plus 40, that is 100 km per hour. So if you put the same value here, the answer will be, your answer will be 60 plus 40. So finally you are getting 100 km per hour. 100 km per hour. But here the answer is 20 km per hour. So keep it in mind that if the bodies, trains, vehicles, whatever car is moving in the same direction, then relative velocity of one with respect to another is obtained by taking the difference of the two velocity. And if they are moving in opposite direction, then the relative velocity is given by addition of the two velocity. That is 60 plus 40, 100 km per hour. Am I clear to you? Yeah? So today we have done the theoretical concept, theory part. This will become more clear when you study the vector chapter. I mean motion in two dimension. So there I will discuss a lot about this relative velocity once again. But since we are dealing relative velocity in one dimension, okay, so this much is enough for the concept of relative velocity. And after solving few problems, the concept will be more clear. Okay, so should I stop today?